In this question on circle theorems, we are told that in the diagram PQRS is a circle and then PQ is equal to QS and angle SPR is given as 26 degrees, and the interior angles of triangle PQS, this triangle here, okay, the interior angles are given in the ratio 2:3:3, and mandate is to find PQR, RPQ and PRQ. In the first case, what I want to point out is that when we are told that the interior angles of this triangle PQS are in the ratio 2:3:3, let's identify those angles on this particular diagram. Okay, since line QS is equal to line PQ, that makes this triangle an isosceles triangle. And one thing we note is that for an isosceles triangle, the base angles of isosceles triangle are equal. And what are the bases? It will be this angle here, SPQ, and this angle here, QSP. So I can say angle SPQ is equal to angle, this is SPQ, is equal to angle QSP, and because they are the base angles of isosceles triangle. Now, in the other information, we are told that the interior angles of the triangle are in the ratio 2:3:3. So which is going to take the least and which are going to be the same? Because we are saying the base angles are equal, then this particular angle here, this will have to be the one in ratio 3 because it is the same as the one here. Okay, so if I'm to say this other one, I can call this one the one of magnitude 2, but that is a ratio. I can actually take a baseline value to say I want to call this 2x, then this one will be 3x. But look at this particular triangle. This is also supposed to be 3x, but already we have taken 26 out of that 3x. So the remainder, just this one, will have to be 3x minus 26. Okay, we just need this consistency so that we'll be able to get our answer correct and out. Okay, so if that is the case, I can say this angle SPQ, which is also QSP, is actually having 3x, and because they are base angles of isosceles triangle, just like this. Okay, now looking further in this triangle, I can identify this particular region here, this angle 26. I can see that it is also the same as this angle here, that is also going to be 26. And why am I postulating that? Is because they are angles in the same segment of a circle. You can see SR is the chord for both of them. We have S going to a point on the circumference, P going to R, then again S going to another point on the circumference, Q going to R. So these are angles in the same segment. So I can also say that angle SPR is equal to angle SQR, and the value is nothing but 26 degrees, and it's because they are angles in the same segment of a circle. So once we have this, we can look at how we can now use this information to try and solve this particular question. In the first case, we have the mandate to calculate angle PQR. Let's identify that PQR, we can see, okay, this we just got to be 26. I can say this is 26. Now from the triangle SPQ, we can see that this angle is 3x. Okay, this whole here is also 3x because the two of them are base angles of this isosceles triangle we are considering, and then this is 2x. The sum of the three is going to give us 180 degrees as the sum of angles of a triangle. So I can say 3x plus, here you can see 3x minus 26 plus 26. The 26 will knock out, so it's also 3s. Okay, then plus 2x, this angle here. Okay, the three of them will add up to 180 degrees because they are sum of angles of triangle. Sum of angles of a triangle is 180 degrees, and this can help us to solve for x. Plus 3x plus 3x, that is 6x plus 2x, that's 8x is 180, such that we can just find our x to be 180 over 8. Okay, that was going to be 18, 18, that is 2, remaining 2, 18, 20, that is also 2, remaining 4. 4 over 8 is 0.5, so x is 22.5 degrees. Then our first mandate PQR, we can see from this diagram that in the first case, angle PQR, what is this going to give us? PQR, this region here, that's what we are looking for, and that is 2x plus 26. And instead of 2x, I can just say this is 2 times 22.5 plus 26. So if we want to add it, you can say 2 times 22.5 plus 26. What is that going to give us? this is going to give us 71. So this is 71 degrees. All right, our first solution is out. In the second case, we are looking at the angle RPQ, and looking at our diagram, this is RPQ. We can see from that diagram that this is nothing but 3x minus 26, and thank goodness we have gotten our x. So this is 3 times 22.5 minus 26. So we can compute this to say, okay, let's just adjust this. So this is minus, and in the first case it is 3 and not 2. Okay, so this is 3 times 22.5 minus 26, and this is what? This is 41.5. So this has 41.5 degrees. And then in the third case, we are mandated to find angle PRQ, and looking at our diagram, this is PRQ, this angle here. That's what we are again asked to find, this angle here. And now there are two ways you can even go about, so even many ways, but two that I'm seeing clearly is that in the first case, you can sum the angles in this triangle PRQ to say this angle that we are looking at, if I call that y plus 26 plus 2x plus 3x minus 26, the sum of the angles in this triangle, that will be 180, and then you can get y hat since we have x already, and that will be fine. But alternatively, I can see that this angle is also the same, even though I'm calling it y, is also the same as angle PSQ. This is also the same as angle PSQ, which we have gotten to be 3x originally. And why am I saying that? Because they are angles in the same segment of the circle. You can see PQ, that is the chord. So we have PSQ as angle in one segment, and PRQ as angle is in another segment. So I can say this is angles in same segment, just like we have gotten one before. Okay, and then that means that the y that I'm looking for, or angle PRQ, is just nothing but 3 times x, and that's 3 times 22.5. And if I use my calculator again, I can just say, okay, let me just remove this last set of entries. 3 times 22.5, that is going to give me 67.5. So this is 67.5 degrees. And you can see how our understanding of the circle theorems, the properties of isosceles triangle, and the sum of angles of a triangle had helped us to solve this question holistically, so that our answers are done and dusted without any glitch at all, and we have the solution fine and good. All right.